Hello, Flavio.
What's
How
going
are
on?
you?
I'm excited for
Hey.
some seizures.
Yeah, further into the lands of encephalopathy.
Oh my goodness, so exciting. So let's do it.
So we're going to be using two terms for the rhythmic and periodic patterns. There's two key terms that we want to learn. One is term one, and the other is term two. So the first term just is whether it has to do with where the pattern is, whether it's localized or whether it's generalized, so occurs both sides synchronously, or whether it's lateralized. And those are the two most common options.
Okay.
There can also be examples where something's happening on both sides, but it's not synchronized, and that would be bilateral independent. You can also have discharges that happen on one side, but there's two different patterns happening at the same time. And so that's unilateral independent. That's fairly rare to see that, but it's possible. And then there's, multifocal, periodic, and rhythmic patterns. And then, so that's main term number one. And most of the time, again, it'll be G or L, but occasionally BI, UI, or MF. The second term has to do with what kind of pattern it is rather than where it is. So you can have periodic discharges, or which are, discharges like we've been talking about, then or rhythmic delta activity. These are waves that aren't epileptiform, and they're not discharges. We'll see in a minute. Or you can have spike and wave. And we've encountered these a little bit before. And for any of these things to be, for us to call a rhythmic or periodic pattern, we have to, technically, we're supposed to see it for at least 6 cycles.
This is an example of how to call something rhythmic or not rhythmic. Because I think it's in EEG reading practices, sometimes it's hard. It's hard to, especially in gray zones, it's hard to know if they're irregular or rhythmic. So this is kind of good to look at. So the 3 examples at the top here are all rhythmic.
Patterns of rhythmic delta activity. Yep.
Right. So to start, so there's slow. So they're delta waves. So they're delta. And from ours, we learned from 0.5 to 4 hertz. And they are pretty similar one to the other, and they come back to back without an intervening background area. So if they're similar back to back, and they're in the delta range, they are called rhythmic delta activity. Is that right?
Yeah. Right. And these could be either generalized rhythmic delta activity or lateralized, GRDA or LRDA, or they could be extreme delta brush, which is another pattern we'll talk about. But we're only seeing one channel, so we can't say which of those it is right now.
Perfect. And then the last point here is that if they are back to back, but they don't look the same, they're not rhythmic.
Right. Look at this. So we have a generalized pattern here. So on left and right, we see about the same thing. And then these are there's no intervening wave between each of these consecutive delta waves. They're just back to back, and these are this is generalized rhythmic delta activity, and it's about 1 hertz.
So GRDA.
Is it 6 cycles? 1, 2, 3, 4, 5, 6, 7. So
it's more than enough.
Yep.
More than enough. Okay. Perfect. So that's GRDA. So similar, but just on one side. So you just change the first letter, right?
Yeah.
From GRDA to LRDA. So from generalized to lateralized, but same description really. So delta waves, 1 to 2 hertz, big old waveforms in the delta range. They're very similar one to the other. They're back to back. So more than 6 cycles. So LRDA.
Yeah.
Right?
And of course, all the other things we've talked about before are going on in the background. We would probably say there's, the delta slowing is generalized, although it's very asymmetric. We would say that there's theta slowing also, and so on. But we'll ignore those things for now, even though they're there.
Famous EEGs.
That's
That's right.
extreme delta brush.
Yeah, they're pretty extreme. So that's the first point.
Right.
They live on the edge.
Yeah.
And I'll take the first big concept, and then I'll let you explain the more difficult one. So the EDB is nothing more than, trying to be simplistic, than rhythmic delta with some exclusive fast activity, right? But that's important because if you see the fast activity overriding the big old rhythmic delta, but also on the background, it's not exclusive. So then it does not count. So it has to be, the fast activity needs to be solely married to the rhythmic delta.
Right. Yeah. So then if we go up to the top, we can see some examples of rhythmic delta activity where there's a consistent phase relationship. So the delta, the hair, is either on the upgoing part of the delta or on the downgoing part. And then the example C is, so you can, in this example, as soon as the rhythmic delta activity stops, the delta or the hair is gone, the hair falls off. So it's possible extreme delta brush. There's rhythmic delta plus this fast activity, but it's not clear that there's a stereotyped, relationship. So we call it possible extreme delta brush now. And the reason we care about this is that it's thought to be pretty specific for a certain kind of antibody-mediated encephalitis or encephalopathy. So the NMDA receptor encephalitis. You see this, there's a good chance that that's what you're dealing with. Especially
on the boards.
Especially on the boards. On the boards for sure.
For sure.
In the real world, you probably have to do the test still.
Yeah, that's
then
right.
The blood test.
Yeah. And just one less, even more rare than this, but I think it's kind of cool to mention, is when you have, let's say, the same pattern as example C or any of A or B, but then you have some background in between. So they're not rhythmic delta, but they're periodic blood discharges, but they're also EDB, right? So it doesn't have to be with RDA.
That you can still call that EDB? Wow, what a world we live in.
Mind blowing.
Ooh, look at this. Actually, this is an example of what you just said, I think.
That's right.
Because these have the hair and it's a consistent phase relationship, but we don't really have, we don't have, I wouldn't call this rhythmic delta activity really. It's not super rhythmic.
Right.
Yeah.
Yep. So the fast activity is with the delta waveforms, but there's some background in between. So should we call this periodic discharges? They're blunt in morphology and associated with faster frequency, therefore EDBs? I
think so. Now, actually, one question: what's the phase relationship? Is it? I guess it's on the down part.
Yeah, that's what I thought too. Yeah.
It's not the clearest example. We don't want to put this in an educational video or a textbook.
Yeah, we would never put it on EEG talk.
No,
never.
It would confuse people, for sure.
So this is another very good example.
Yes.
And the slide is calling for action. They're asking us if we can identify where the delta brush occurs in this montage, or image, not montage.
I think we can.
I think we can try.
I bet if you hit next slide. So it looks like it's primarily on the down slope, although it's, truth be told, it's it's on the top too, but I guess it's much more on the down slope than on the up slope.
And I think this we can call rhythmic delta, right? Because there's no nothing in between. Pretty good.
This is generalized rhythmic delta with plus F.
Right. AKA
EDB.
EDB. Got that under control. Now we should go to periodic patterns. So like we mentioned, number one, the discharge doesn't have to be necessarily epileptiform. So they can be epileptiform or not, but it doesn't matter for the big periodic discharges definition. So for example, here in the top, they're pretty blunt. We wouldn't call this an epileptiform discharge, but they're periodic. Therefore, they're periodic discharges. But here at the bottom, it's a different story.
Yeah, this is maybe more common. The sharp waves or spikes occur periodically. Yeah. So let's take a look at some real ones.
Let's do it. And then just one highlight here. It's counting for us because it's got to be 6.
Oh, thank you.
Beautiful.
GPDs. So these are left and right. They're symmetric, right? These are so bilaterally synchronous, generalized periodic discharges. The period is about, let's see, how many per second? Most of the time it's 1 or 2.
Yeah.
So
yeah.
In some seconds you see 2, in some seconds you see 1. So it's let's call it 1.5 hertz.
And then we have the triphasic morphology, Dr. Peter Kaplan's favorite EEG finding.
Indeed. So yeah, these have 3 lobes. There's an up one, down one, and another up one and they get progressively bigger typically.
So let's look at this big boy here. So I think they're same GPDs as you just taught us. So they're generalized, they're sharp probably here, not spiky, sharp. They're discharges, they're more in the front, they're periodic, there's more than 6. But if you imagine a line here in the middle, they cross the midline 1, 2, 3 times, so 3 phases, right?
Yeah.
So they're triphasic morphology.
Yeah.
Cool.
GPDs with triphasic morphology.
LPDs now are very similar. They're periodic. There's more than 6 of them. There's periodicity to them, but they happen on the left hemisphere only. So we can't see anything on the right as far as discharges. So they're lateralized, right?
Right. I would say the frequency is about 1.5 hertz.
Yeah.
A little more than 1.
And maybe there's a brief attenuation here, but that's for module 4. So
yeah.
Not there yet.
Maybe being treated with a drug that's going towards suppressing the EEG. And again, another example we probably would not want to put in EEG talk because
blasphemy.
It's not classic, but I think this is an example of bilateral independent periodic discharges. So for that to be true, we have to see that there's periodic discharges on both sides, but they're not synchronized. So let's look at the left side first. So the FP1, F3, yeah, there. So I think, you have to a little bit squint to see that these are continuing periodically, right? It looks like sometimes it's easy to find them, and then there's just hints in between. Yeah. But we'll say that this is periodic at maybe 0.5 hertz on the left. Okay. That's true. And then if you go to the right, so the FP2, F4, that complex. So there, yeah, I think you can see periodic discharges as well. They maybe stop and start, but they are not always. If you look,
so for example, at the one, let's see, so 1, 2, 3, 4 from the right. If you go 4 from the right, the red one, yeah. Go down. Right. Yeah, let's to the left of it. Yeah, so that one.
For example, it's if you look at the corresponding location on the left, there isn't a discharge there. Right. And I think for many of these ones on the right, there are actually not corresponding discharges on the left. So we have, and that's the frequency on it's a little faster, I think, than on the left, right? So it's almost 1 hertz, which is faster. So yeah, these are non-synchronized, bilateral independent periodic discharges.
Yeah. Sounds good. Got it. Seizures now.
And birds. Mm-hmm.
Nice one.
Tasty.
You wanna
Yeah, so here we go. This is a focal seizure, right? So we see this. So first let's describe it. So it's first the location of it, and it's very nicely circled. It's in the left posterior kind of quadrant, those last two chains. The frequency we see, I think it's rhythmic activity, and it's in the theta range. So at least at the beginning, it's 1, 2, 3, 4, 5, 6 hertz, I think. So, and then you can see some evolution, I believe. So at the beginning, on the left-hand side of this, it's really theta waves. They're not too spiky. Mm-hmm. And then as you go toward the right, as it progresses, you see most of the peaks of these waves they're epileptiform, right? So it has epileptiform discharge. So there's this evolution of the morphology, but it really stays focused on the left side, left posterior quadrant. Yeah. So it's a focal seizure. There's probably something wrong back in the left, occipital area. Maybe could be a tumor or a stroke or an infection or an injury back there.
We have a generalized seizure. I'll take a stab at this one. So pretty slow background that we already learned. Maybe some attenuation that we will learn next module, and then some generalized. I think the gain here is a little bit off, but periodic, every 3 seconds, 3 to 4 seconds here, 5, I guess, hertz. Generalized everywhere, discharges that evolve into something more interesting here at the end, which looks like a generalized seizure.
Very fast, high voltage, very spiky activity. This is a generalized seizure.
Perfect. So we saw focal, now we're seeing generalized seizure. Now we know how they look like. And one of our favorites.
Birds. Why don't you take this one?
Ladies and gentlemen, we have our birds. Yeah. And this is a good example from Dr. Hirsch's slide from another set of videos that we did. And did just cover essentially what we talked about in this module and prior module on interictals. So starting on from the left, you can see that there are some sporadic discharges that seem to be generalized. See them everywhere. Not periodic, because there's no more than 6 cycles, there's no periodicity, but you have a run here and then one over there. So it's sporadic generalized discharges. And then they organize into these birds that stand for brief, potentially ictal rhythmic discharges. So just to recap on the definition, they have to be shorter than 10 seconds, but greater than half a second, and they have to be 4 more hertz. So this one fits. So 2.5 seconds, and they're 1, 2, 3, 4 to 5. So at least it fits at least 4 hertz criterion there. And then they evolve into seizure. So you want to take the seizure?
Yeah, actually, I'll also note that they are in the same location as the spikes that the sporadic discharges we were seeing earlier. And they're also in the same location as the seizure that we see there on the right. So those, and then the seizure is just kind of a long bird, or a bird is a short seizure. Yeah. So that in this seizure we see, there's rhythmic activity in it, and there's discharges with each of the rhythmic kind of delta waves, and it looks like the frequency of those discharges is about 1, 2, maybe 3, I think. Yeah.
Okay. Yeah, and then the point you brought up is really important, because the fact that they are arising from locations where, in this case, it's a little bit easier because they're more generalized, but because they arise from the same area, from interictals or seizures, in this case, both, they're called definite birds, right?
Yeah.
So they're for sure birds. So that's a good example. Thank you, Dr. Hirsch.
Should we wrap up?
Let's wrap up.
All right. So let me take the first 3. So these are different types of rhythmic delta activity. Typically, the first 2. So GRDA is bilaterally synchronized rhythmic delta activity. LRDA is just on one side. And then extreme delta brush is sometimes rhythmic delta activity with fast activity on top of it and exclusively associated with it. So if it stops, the fast activity goes away. Often there will be a consistent phase relationship of the fast activity, either with the up or the down part, or maybe the top. But you can also call something extreme delta brush if you have blunt, recurring discharges, if there's this consistent relationship of the fast activity with those.
Yeah, perfect. Okay, so I'll take the periodics. So they're discharges. They can be epileptiform or non-epileptiform in case of more blunt discharges. They happen at a certain frequency that's periodic, therefore the periodic term there, and they can come from either both sides at the same time, synchronically, in which case they get the G for generalized, or they can come from one particular part of the brain, one focus, in which case they get the lateralized modifier there, or they can come from two independent foci, one from each hemisphere of the brain, and that will give them this bilateral independent term. And I'll give you the seizures.
Good. Yeah, so seizures can be either focal or generalized. And so focal means that the seizure activity starts locally. Generalized means usually means that it starts bilaterally at the same time. But of course, you can also have seizures that begin locally and then generalize subsequently.
Great. Okay. And last but not least, are BIRDs, that stand for brief, potentially ictal rhythmic discharges. In terms of duration, they must last between half a second and 10 seconds, and they have to be at a frequency of 4 or more hertz. I think that's it for today.
That's it.
Cool. See you in Module D.
See you in Module D.